All right, we're working on 10.5.3, factoring and graphing, and as always, we're just going to jump into the checkup problems. All right, what we need to first discuss is what in the world does the term zeros mean? All right, so zeros or x-intercepts or roots. So zeros, x-intercepts, or roots are all talking about the same thing, okay? So if you hear any of those three terms, they're all talking about the same thing. And what that is where the graph crosses the x-axis. Where the graph crosses the x-axis. So here, the graph is going to cross the x-axis at x equals, I don't like that, sorry. X equals positive 2 and x equals negative 1. Those are my two zeros. They cross at negative 1, they cross at positive 2, those are the zeros. Over here, these are going by 2, so this is 2, 4, so x equals 3, x equals negative 3. Those are my two roots. It's where it crosses the x-axis. All right. Now we want to find the factorization. Okay, so, and we're going to assume there's no constant term. Cool. So, find the factorization of how we do it. We're going to do it the same way we did the first step. We're going to identify the zeros. So we cross here at x equals positive 1, 2, 4, 6, so x equals positive 5. So what I have here is I have x equals 1 and x equals 5. I'm going to get them on the same side. I subtract 1, subtract 1. X minus 1. Subtract 5, x minus 5. Put them together, I have x minus 1 multiplied by x minus 5. That's my final answer. That's what they mean by factorization. So I get my roots as positive 1, positive 5, and I take the opposite. I make it look negative. So it's x minus 1, x minus 5, even though they cross positive. So it's kind of opposite of what we think. Now here, it touches at x equals negative 2. Well, x equals negative 2. Well, this is a negative 2. It needs to look positive. So it's x plus 2. All right, so again, it's always opposite. These are factors and roots. So what I have in parentheses here and here are called factors. And then x equals x equals x equals are called roots. They're called zeros. They're called x-intercepts. And then roots, zeros, and x-intercepts are always opposite of the factors. So x equals negative 2, our factor is x plus 2. Now, one thing to note is this all their other graphs crossed the x-axis, went down to the negatives, and came back up. This graph is touching at the x-axis and going straight up. It is not crossing into negative territory. All right, when you have this scenario where the graph is just touching the x-axis, you take your factor, which we got x plus 2, and you square it. So anytime you have a situation where the graph is touching, we get our factor like we do on everything else, and we just put a square next to it. All right, now identify the zeros of the function. So I'll do the full way we're supposed to. This is supposed to be 0 equals x minus 5, x minus 11. And what we have to remember is if we have a situation where we have a times b, and we want the result to be 0, well, anything times 0 equals 0. So in this situation, a times b equals 0. A could equal 0, or b could equal 0, and or I guess. Right? Only one of a or b needs to be 0 for this equation to work, right? Because anything a is times 0 is going to be 0. Anything b is times 0 is going to be 0. So only one of these pieces need to be 0. Well, if I expand this is essentially what we have over here. X minus 5 times x minus 11. So what I need to do is I just set them, x minus 5, and I set it equal to 0. Add 5, add 5. I have x equals 5. Do the same thing with the 11. X equals 11. All right, sweet. I wanted to do that one. So x equals 11. All right, now let's do it, right? Because again, we have roots, x equals 11, or zeros are x-intercepts, x equals 5. And then we had our factors, x minus 5, x minus 11. They're always opposite. So a quicker way to do this, if I'm given this form, question 6 here, x plus 1, what's a 0? X equals negative 1. X minus 9, positive 9. Done. It's just always going to be opposite. All right, now for questions 7 and 8, you will need to follow those factoring steps we did either last section or 2 sections ago, whatever they may be. So what I'll need to do is I have a plus and a minus. So my cheat sheet says I should have an x plus factor and an x minus factor, right? And I'm just going to go quickly through this because we have a whole nother video that talks about this stuff. And then 56 going to be 8 and 7. All right, so I know 7 is going to end up being x plus 8, x minus 7. Again, if you don't know how I got that, there is a video a couple sections before when they're talking about factoring x squared plus bx plus c. I think it's section 2 of unit 10. Watch that video and it will go through the details of how to do this. Now, what are the zeros? X equals negative 8, right? It's x plus 8, so I take the opposite, and x minus 7, positive 7. Always going to be opposite. I'm done. All right, so let's look at 9. The path of a diver diving off a 10-foot platform can be represented by the equation they give us, where h is the height above the water and x is the horizontal distance from the platform. Find the zeros of the function. Well, this is easy. All I need to do here is take this piece and factor it. All right? And again, the factoring steps are in the other video. But I know this is going to be x minus 7, x plus 3 are my factors. I factor this is what I get. And then that tells me my zeros are then going to be positive 7, because it's going to be opposite, and negative 3. All right, so positive 7, negative 3. We have the same equation and everything. What does the positive 0 represent? Okay, so the positive 0 is a 7. So that means when, I believe if I'm thinking of this question right, is when, right? Because we know it's the x-intercept across the x-axis. This is going to be where the diver hits the water. So when he dives off of the diving board or whatever it's called, he's going to hit the water at x equals 7 feet. So he's going to be 7 feet away from the platform when he hits the water, right? Because we're going to assume that the water is our x-axis, right? We're above this. This is our platform. We are, what, 10 foot high. And we basically have an arc, we'll say, right? We're here, he dives, and it looks like that, right? Now, why don't we continue the parabola? Like normally if we graph this function, we'd have a second half of this, right? Well, the reason we don't is because that's the negative. He's not jumping, he's not jumping backwards. He's not jumping onto the concrete, right? He's going to jump into the pool. So we only have one direction to go, and that's this way. And then they're going to say that this point where he hits the water is 7 feet. So that's what that positive 0 means in the context of this problem.